Welcome to part 1, where we're going to cover some of the formulae that we're going to go through, and you'll see at the beginning of each video I'll just place where we are. So we're in part 1 and we're on the first video here on distance, which is A. And for each of these we might go through a few examples for some of these as well. So let's dive let's jump and dive straight into it. So the first question is, do you remember Pythagoras? Well, it should hopefully be somewhat of a rhetorical question because, yes, we've got that theorem we always use and see those Pythagorean triples. So let's take 2 points on the Cartesian plane, and I'm going to give you these points of A, I'm going to say is at 3, 2. And B is going to be over here somewhere, and let's put B at 6, 6. Okay. And what we're looking for here is what's the distance from A to B if we were to draw a very straight line. So hit a pause as you need to jot down the diagrams. They're not too many, so hopefully they're accessible to draw down. So there are our points, and we're trying to find what's this distance AB. Now, you may see it already because I've mentioned Pythagoras. I'm going to say, well, let's see this x distance over here from 3 to 6 is 3. And you're thinking, oh, well, how did we get that? Well, we saw from 3 to 6 was 3. Or we went 6 minus 3. Okay, and this distance over here, if we went straight up, is 4. So we've gone from 2 up to 6. We've gone 6 minus 2 gives us 4. And then if we recognize the Pythagorean triple, we might see, oh, well, that's 5 because we've seen enough of these triangles. Or you might think, wait a second, for that distance, we've gone, the distance is, and we took the square root of 3 squared plus 4 squared, because 5 squared is 3 squared plus 4 squared. Okay, so let's see what happens now if we look at this more in general and say, well, let's have some sort of point here of point A. Doesn't matter where A is. And let's have point B over here, and it doesn't matter where it is, and we're looking at that distance. Now, for simplicity's sake, I'm working in the first quadrant where everything's positive. It doesn't matter where we are in the Cartesian plane. So let's draw our triangle for one last time. So let's draw this and that and say, well, if we've got a right angle triangle, to find this x distance here, we took the x value of B minus the x value of A, 6 minus 3. So in general, we're going to take xB minus xA. Okay, easy enough. And we're going to do a similar thing for this 4 that we found over here. We went 6 minus 2. We took the y value of B minus the y value of A. So part of this section is also getting used to writing, xB. Oh yeah, that's just a way of saying the x value of point B. So then if we wanted to find this distance here, well, we'll do it the same way we did the previous one. We took the square root of 3 squared, but this was this x distance over here. So it was xB minus xa squared plus, and we squared that y distance, which was 4 in our example, but in general will be something like that. Okay, so there's our, let's move to the right side. There's our distance formula. Not some crazy formula out of nowhere. It's just Pythagoras. But now we don't have to draw a triangle every time. So let's go through 3 examples where we can practice this. And remember, just hit a pause when you need to, and then obviously move on. So there's our formula. So determine the distance between points A and B, and they're the coordinates. So all this is an exercise in saying, let's plug this into our formula. And our formula is given to us on our formula sheet, but after a bit of use, we'll probably get used to writing out. You can see I'm kind of in a template-y mode here where I go, oh, no, it's going to be something minus something squared. So now we can just put our values in. So I'm going to go this -2 and this 3. Doesn't matter what order we do it, but let's be consistent. So I'm going to go B minus A. So I'm going to go 3 minus -2. And that came from those 2 bits there. And then our other value over here, I'm going to say is the -1 and the 5. And all I'm doing is I'm going to be consistent and go 5 minus -1. Now, because we're squaring it, maybe you'll see that it wouldn't matter if we went -1 minus 5, because it's still going to be 6 squared or -6 squared. Okay, then you can plug that all into your calculator or work it out manually and go, well, 3 minus -2, 5 squared, that's 25 plus 6 squared plus, more of a kind of just pop it on the calculator. Seems a bit easier. So let's have a look here. We've got the square root of 3 minus -2, I know is 5. So I might save myself some time and just write 5 squared or type that whole thing in. Depends on your level of comfort. 5 minus -1 is 6 squared, and we get root 61, so square root 61, and I might say that's approximately equal to, press the S to D button, 7,81. Didn't say if we wanted it 81 in simplest third form or in decimal, so I'm just going to put both to be safe. Okay, so that's our first example. 2 more examples. Maybe they'll get more interesting. Let's have a look. Show that the points A, B, and C form vertices of an isosceles triangle. So one way just to start this is, let's get ourselves a little Cartesian plane. I just wanted my axes to be like this and go, okay, so very quick sketch just to see if we can see what's happening. I think a little diagram can be useful. That's my X and Y axes. So we've got point A is at -2, 0, -2, 0, somewhere over there. I've got point B, and B is at 1, -4, so somewhere down there maybe. And C, I'm doing over here, and let's do that one maybe like that. Is that a bit different enough? And C is at 2, 3, somewhere over there. Okay, I don't know if that really helped, but, you know, it is funny enough just to draw a triangle, and there it is. I'm not sure which two are going to end up being equal. With my diagram, you know, if C were way up here, it might give us an indication. So let's just work out all the distances. So the distance of AC, notice the way I'm writing it, is the square root, a wobbly square root of, and we're going AC. So I'm going to go 2 minus -2. And I'm going to go 3 minus 0. And into the calculator it's going to go. I'll do it just now. I'm going to do D, maybe AB next, and see what that's going to give us. Squared plus squared. As I said, pause as you need to. Pause, actually plug it in, check how you're doing, and then see how the video. I'm not going to leave a lot of time. And let's have a look there. That one's going to be AB, so 1 minus -2, and -4 minus 0. And it's good to show this step. We're just showing that we're subbing in. And let's get the calculator back out. And hello, calculator. And go the square root of 2 minus -2 squared. I think that's 4 plus 3 squared. Well, I can actually see where that's going. Hopefully you can see what the answer is going to be here. That's going to be our beloved 5. And then let's do the same. Maybe think why I'm pausing. Why am I not working out the other one just yet? Square root of 1 minus -2, 3 squared. Well, that looks like it's going to be 4, whoopsie, plus 4 squared. Again, maybe you can preempt. Maybe we didn't need the calculator after all. Well, that's 5, so I don't need to work out what BC is. It looks like AC, let's keep it, that is the same as AB. So my sketch wasn't so useful. So show that it's an isosceles triangle. Well, we might want to sum up and say the distance AC is equal to the distance AB, therefore isos triangle. Okay, and let's move that out the way. Those two are the same. Okay, let's head into our final example. Distance between a and b is 5, determine the value of t. Now there's a variable involved here. But let's just use our formula. We know that that distance is 5. So the distance is equal to the square root of something squared plus something else squared. Well, I'm going to go definitely the b values minus the a values, because I think seeing t minus 3 and squaring that is going to be easier to deal with. So if I'm doing that, then the other one I'm going to go 6 minus 2. Okay, well, go for it, pause, solve, but I'm going to carry on merrily here. I'm going to square both sides. And at the same time, 6 minus 2 is 4. 4 squared is 16. Plus t minus 3 squared. I'm not going to square that out. And then let's make that 3 a bit clearer. I'm going to subtract 16 from both sides. 9 equals t minus 3 squared. Now I know that the square root of this must be one of two options. Either t minus 3 must be negative 3, or t minus 3 must be positive 3. Because remember, if you're squaring either of those, you'll get 9. These brackets aren't giving us too much, so add 3 to both sides, t equals 0, or our second solution, t equals 6. Now I'll leave it to you to do a little sketch here to see what's going on, because I think it's an interesting idea of, well, A is at 2, 3, and B is at 6t, and why there are two possible values of B to give you the same distance. Both of those were 5. Think of the isosceles triangle from before. Okay, that brings us to an end of our first formula on distance. I'll see you for the next one on midpoint.